Hello everybody and welcome to the final A2 Carlum Cymru revision session. The session this evening will be focusing on A2 Pure, looking at Newton-Raphson, the modulus and differential equations, and will be presented by Mr Mackenzie of Porthcawl Comprehensive School. The session will last around 45 minutes and Mr Mackenzie will go through all the relevant content and examples. If you have any questions during the session, please use the Q&A section and we'll do our best to answer you. And I've put a hyperlink in the Q&A section, so if you're happy to leave your name and email address, we would love to keep in touch with you so we can send you information about future events. You can click on that link anytime during the session. You can pause the session whenever you like as well if you want to have a go at any of the questions. Okay. Today's session will be recorded, and the recording and any relevant resources will be uploaded to the e-sgol website under the Carlum Cymru tab. Thank you, Mr Mackenzie, and over to you.
Thank you, Mr. Weatherhead. So last time we looked at numerical analysis, where we went through the trapezium rule, iteration method, and I think I did one question on the Newton-Raphson. So I thought I'd like to start with a couple of questions on Newton-Raphson to make sure we're all happy with it, then moving on to the modulus, and then finally differential equations. As Mr. Weatherhead said, on the e-sgol Carlum Cymru website, there's pretty much a full package of pure videos and sessions that you could go through that have been covered over the last 3 years. So if you are needing a little bit of work covered, or if you want to sort of have a look at sort of more complex questions, you can sort of look at the video, try the questions yourself first, and then sort of press play and work through it. So the first one we're looking at is Newton-Raphson. There's not that many Newton-Raphson sort of questions out there, so I've had to sort of borrow a few from the further maths. It's more the differentiation, I think, is the only thing that's going to be more complex. The actual formula itself is given and is of the form, if I was to write it here, x to the n plus 1 is equal to x to the n minus f of x to the n over f dash of x to the n. So that's the formula. So what they're going to really test is the actual differentiation element of things. You're told here, so you're given the equation x cubed plus 4x squared plus x minus 1 equals 0 has a root alpha. And like I said before, alpha is the sort of symbol they use for the root. You're also told it's between -1 and 0. Show that the Newton-Raphson iterative formula for this equation can be written in that form. Sure, maybe sort of had a bit more space, but if I write it down in this corner here. So we know f of x is already equal to 0, so we're good to sort of put that one in. So it's going to be f of x equals x cubed plus 4x squared plus x minus 1, and then f dash of x is again just differentiating it. This is the sort of symbol used for it, or the notation used. So it's going to be 3x squared plus 8x plus 1. We then need to substitute it into the formula above for the Newton-Raphson and simplify it out to give you what you needed there. So if I was to write for part 1, x to the n plus 1, that is equal to x to the n minus x cubed to the n plus 4x squared to the n plus x to the n minus 1 over 3x squared to the n plus 8x to the n plus 1. What I really need to do is write this element here as a fraction so that I can combine the two. The only way I'd be able to do that is if I times top and bottom by the denominator on the other side, which would be 3x squared plus 8x plus 1. I'm going to write that in here. So then that is equal to x to the n over 3x to the n squared plus 8x to the n plus 1 minus, and then what you've got here and then that's all over 3x squared to the n plus 8x to the n plus 1. And if you have a look, the denominators are now exactly the same. So it would be a case of expanding this bracket and then collecting like terms. So you can already see that that is going to give me 3x to the n cubed minus that. So it would be 2x cubed to the n. And then I'm going to have 8x squared minus 4x squared. I should have put the bracket there. You are sort of, well, not allowed, but they will accept divisible brackets if you do make sure that you have multiplied by that minus sign. But obviously putting brackets in would make it sort of much nicer. So then you've got 8x to the n minus 4x to the n. So it's going to give you your plus 4x to the n squared. And then you can have x to the n minus x to the n, which goes. And then you've got minus 1. So that becomes plus 1. And then you have underneath the 3x to the n squared plus 8x to the n plus 1. So we've done the first part. Part 2 then is using the initial value of x to the 1 is equal to minus 0.7. Find the values of x to the 2, x to the 3, and find alpha correct to 5 decimal places. So they're expecting you to put in and work out x to the 2, x to the 3. You're going to have to then continue going 3 or 4 times so that you get the answer correct to 5 decimal places. That means you have to have the same number 6 decimal places after the point so that you know whether you're rounding up or down for the for the 5th number. Now, sounds really complicated, but if you use your calculator as best you possibly can, so we know that x1 is equal to minus 0.7. Because we've got this now here, x2 is equal to 2 times minus 0.7 cubed plus 4 times minus 0.7 plus 1 all over 3 times minus 0.7 squared plus 8 times minus 0.7 plus 1. That gives an answer of, because I've already worked these out, minus 0.7265176. Because we want it to 5 decimal places, I would probably go much longer, but even better than that, I would just, sorry, that should be 2. I would just then, for the next one, you could even have put minus 0.7 equals into the calculator. So you, instead of putting all of this in, what you're going to do is, into your calculator, you're going to put ANS. So ANS just takes what answer you had before and puts it into the function that you're trying to work out. Squared 8 times ANS plus 1. So now x cubed, or x to the 3, sorry, is minus 0.7261095. And then you just put equals, and then you've got x4 straight away, which was minus 0.7261009. Okay, that's a 4 now, but that's 1, 2, 3, 4, and then there's your 5th one. They're both the same on there, so that might actually go down, but to 5 decimal places, then alpha is going to equal minus 0.72611. There is a 1 there. A question might ask you, when would you not use Newton-Raphson? So the best way I can describe it is you would pick the best tool that you've got in your arsenal for the job. So if you were just trying to work out whether there was a root there, you would use the change of subject. Not change subject, you would use the sign change, so it was a plus or a minus. You wouldn't use the Newton-Raphson for that. And if you were having to sort of work out via trial and improvement, 1 number to 1 decimal place, then again, you wouldn't use Newton-Raphson, because you can see already from 0.7, we have got to 4 or 5 decimal places straight away. So you wouldn't use it. It's the equivalent of using a sledgehammer to sort of hammer in a nail. So the best way I can sort of describe it is you would use what's fit for purpose. So something for 1 or 2 decimal places, you would use the iterative method. Newton-Raphson is 5, 6, 7, or even 8 decimal places what you're looking for. I got one more only because I find that the differentiation is a little bit more complex. So it'll be interesting, well, not interesting, it'd be good to sort of show you, to get you used to it, is going to be the product rule. So it says that alpha is found using the Newton-Raphson method. with f of x equals x e to the minus x plus 1, crosses the x-axis at x equal to alpha. Use this method with first approximation x1 equal to 0 to find the next 3 approximations, and then find alpha to 3 decimal places. So again, we have our f of x, which is given to us, x e to the minus x plus 1, and then we're going to have to do f dash x. So this is going to be the product rule because it's a function multiplied by a function. So if I would sort of set it out as u equals x, and then v equals e to the minus x. Du by dx is equal to 1, dv by dx is minus e to the minus x. If you, it's always useful to write down the formulas, because if you put the formula in and you make a mistake because you've shown which formula you're using and it's the correct formula, you pick up a method mark. But if you then just put down your sort of values in, which you think is the correct product formula, and you get it wrong, then because you haven't shown a method, you would lose a mark. So it's always useful to show it or to put it in some place. So it is v du by dx plus u dv by dx. It's basically the opposites added together. So if I go e to the minus x, and then this is going to be plus minus x e to the minus x, which would be looking like so. So now we have our f of x and f dash x. So when we put it into the Newton-Raphson, it is x to the n plus 1 is equal to x to the n minus, and then on top we would have f of x, which is x to the n e to the minus x to the n plus 1 over the differential of it, e to the minus x to the n minus x to the n e to the minus x to the n. Excuse me. Again, that's going to be the value that we're, well, this sort of the formula, and that's going to take up, if you notice, it's worth 5 marks there. So you're going to have to differentiate it and put it into the formula. So that's going to be 3 out of the 5 straight away. As I said, there was another section to this part, but because it was irrelevant, I didn't bother putting it in. So now we were going to put in, we're told that, what have we got? X to the 1 is equal to 0. Now, I'm sure you can, and I'm sort of aware of time, I'd like to move on to the other 2 sort of topics. You can easily put these into your calculator. I'll probably do 1, and then I'll write down the or how I did it, because there's quite a lot e to the n's. So I took them individually. I mean, I'm not sure, there's not going to be a problem if you didn't. But if we did x2, that is going to be 0 minus. So that is going to be 0 times that, so it's going to be 1. Divided by that is going to be 1 as well. That equals minus 1. X to the 3 is going to be, and I'll put the individual values in. So that's minus 1. And then minus, I got a minus 1.71828 over, and that was 5.436563, and that was equal to minus 0.6839. And then if I just put the others here, x to the 4 is minus 0.5. Oh, I missed one. That should be x to the 2, and then that's x to the 3. Oh, sorry about that. Transferring from the paper. So that's x to the 3 minus 5775. And then you got x to the 4, which was equal to minus 0.567, and that is to 3 dp. And there's nice 5 marks. Okay, so that's the end of the Newton-Raphson. We're going on to the modulus. So here you're going to have to, if you have a look at the advanced knowledge, it's going to ask you to solve, I think, and it's also going to ask you to sketch. So you're going to need to know how to sketch the modulus. These straight bars here symbolize that this is the modulus. So how you would sketch it would be to sketch y equals 2x plus 4. So you know it's going to be here. Now, the sketch of that would mean that you're looking for where it's going to cross the axes. So it's a gradient of 2, and it is a y-intercept of 4. So it's a positive gradient. It's going to be there. So that's going to be 4. And then because of the fact there's a gradient of 2, this is going to be minus 2 here. So that's the sketch of that. If we were then going to sketch the modulus of that, what the modulus means is it doesn't want anything to be negative. So at this stage then, this comes straight down here like so. It hits the axes and it bounces off over in this direction. So it becomes a V shape. So then the purple line would be the modulus. So if you were to do, let's do y equals the modulus of, let's do x minus 5. So again, you've got your line like so. You know minus 5 is down here, okay? And it's not only that, it's going to be parallel with, because it's going to be 1, so it's 5 and 5. So it'll hit there like so, and then it'll bounce in this direction like so. So you've got 5 there, and you've got 5 there. So that would be the sketch of the graph of y equals x minus 5. One more sketch on the other side would be, I couldn't find the squared button on when I'm doing the PowerPoint. So this is y equals x squared minus 4. So again, what you need to do is you would sketch your original function. So sketch the original without the modulus. We're looking at sketching y equals x squared minus 4. How you would do that, excuse me, how you go about doing that would be, you want to find out what it equals on the x and y axes. So if you put x equal to 0, then you have y equal to minus 4. If you got y equal to 0, x squared is minus 4 equals 0. X equals 4, sorry, x squared. X equals plus or minus, which is equal to plus or minus 2. So again, the sketch would be that it would be a U-shaped graph going through at minus 2 and 2 and going down here at minus 4. So if I choose a different color. So the modulus of that then would be that you wouldn't have anything below the x-axis. So it'd come down and then it would bounce, and then it would bounce up. So then it's going to be minus 2, it's going to be 2, and then this minus 4 is going to be 4 here, which when solving the equation, instead of, if we said, I don't know, this was going to be when y is equal to 3. If y is equal to 3, is this dotted line here, you're going to have 2 roots for it, where they cross, or 2 interceptions. If you've got y equals to 3 for the modulus one, then you're going to have 4 different values, which is why it's important sometimes to sketch it or use the technique of solving equations, which I'm going to show you on the next slide. Before I do that, I thought I'll do one more with you, and this time I would choose a cubic. So if we've got y equals the modulus of x plus 4, x minus 1, x minus, let's do 7. I've written it in terms of its roots just because this could be added with the factor theorem, but that's in AS level, so they would probably just give it to you in this format. How you do it, again, like I did up here, if I was to put x equal to 0 for the original graph, if I put it over here, so if x, sorry, I need to go back. if I was to put x equal to 0, there we go, sorry, from current slide, and press the button. If I was to go x equal to 0, then what would happen is it would be 0 in all of them. So it'd be 0 plus 4, 0 minus 1, and 0 minus 7. So it's going to be minus 4, because 4 times minus 1 is minus 4 minus 7. So it's going to give you plus 28. So when x is equal to 0, y is going to give you 28. And then if you put y equal to 0, you're going to have x plus 4 is equal to 0, x minus 1 is equal to 0, and x minus 7 is equal to 0. So x equals minus 4, x equals 1, and x is equal to 7. So the graph of which, without the modulus, will be minus 4, 1, and 7, and going through 28. So it'll come up, down, and up. So the modulus of it would look like, if I choose another color, blue. So the graph of the modulus of all that would be that it wouldn't go. So it'd come from here. So I should have put in the numbers as well. So that's minus 4, 1, and 7, and that's 28. So it's going to be hits there, 1 again. So it'll come from here and then bounce up and then bounce up and then go off. So that would be the modulus of the qubit. Okay, so moving on, hopefully no more technical issues. We have solved the equation of the modulus of 5x plus 4 equal to minus 7. Now, there are two ways in which you can solve this. I have my own preference to how I would solve it, but I know other sort of teachers have probably taught it one way or the other. If you think of the graph of them, they would be sort of, again, they wouldn't be in the negative region, so they'd be bouncing out. So what you do is method 1, you would take the normal element of it. So it's going to be 5x plus 4 equals minus 7x. And then you would rearrange and you'd solve it. So in doing that, you would have, take the minus 7 over. So then that's going to be 5x plus 7x equals 4. So you've now got 12x is equal to minus 4. So then x equals minus 4 over 12. X is minus 1/3. And then because of the fact that it couldn't have been minus, so now it is minus because you've taken it away, you would then do minus 5x plus 4 equals minus 7x. So you've now got minus 5x minus 4 equals minus 7x. And solve that. So bring that over, take that over. So it's going to be minus 5x plus 7x this time equals 4. 2x is equal to 4. X equals 4 over 2, which is 2. So those are the two values you're looking for. Now that's method 1. As I said, you make one, you keep it as positive, work it out and solve it. You change it to negative, work it out and solve it. Now, how I prefer to do it, which would be method 2, and I'll use a different color pen. So method 2 is you square both sides. Square both sides, and in squaring both sides, you're going to get a quadratic, and then you solve that quadratic. How you solve that quadratic is either by factorizing or completing the square or using the quadratic formula. So you're going to have 5x plus 4 all squared equal to minus 7x all squared. there's nothing wrong with using smiley face or foil on this, but when it's a bracket like so, I prefer to square the first, square the last, and then twice the product. What I mean by that is square the first, so square 5x, so that gives you 25x squared. Square the last, so that's going to give you plus 4 all squared, which is plus 16, and then twice the product. So that's 4 times 5x, which is 20x, and then double it is going to give you 40x. And then that is minus 7x all squared, so that is 49x squared. Because the 49x squared is positive on the right-hand side, I'm just going to take everything over. So that I would have 49x squared minus 25x squared minus 40x. I like to put them x squared x, and then x just makes it easier. Minus 16 equals 0. 24x squared minus 40x minus 16 equals 0. Hope you can all see that 8 goes into each of these. So it would be 3x squared minus 5x minus 2 equals 0. 3x and x. One positive, one negative, so it's going to be have to be a 2 there and a 1 there. I want that to be a minus and that to be a plus. So when we then put 3x plus 1 equals 0, 3x equals minus 1, x equals minus a third, x minus 2 is equal to 0, x is equal to 2, which is exactly the same answers we got on the left-hand side. So from now on, I will be using method 2, which is the idea of squaring both sides. On the next one, if you notice, this has got an inequality, so you have to think back to your AS sort of questions when you have an equality. Notice also, whereas a normal inequality, solving it with a quadratic, is going to be 4 marks, the marks here are 3, because it is not such a difficult skill, because you're going on to A2. So the question has said, find all values of x that satisfy the inequality there, which was 3x minus 5 in the mod, and less than or equal to 1. Okay, so as I said, I'm going to take the sort of root of squaring the values. So look what I got left. And in doing so, we would have 3x minus 5 all squared less than or equal to 1 squared. So you would expand the brackets. There's nothing wrong with taking them to the one side and putting them down as 2 brackets. But again, I'm going to use the technique of square the first, square the last, and twice the product. So 3x squared is 9x squared. Let's do the middle of it so it goes into that format. 3 times 5 is minus, sorry, 3 times minus 5 is minus 15. So that's going to be minus 30x. And then that would be plus 25 less than or equal to 1. So it is 9x squared minus 30x. Take the 1 over, so that's going to be plus 24. Divide it all out by, I think 3 in this time, yeah, 3. So it's 3x squared minus 10x plus 8 less than or equal to 0. And it's got to be 3x, is the only thing, is because x is a prime number. 8 would be 4, because I want 12 and 2. So if I put 4 there, that's going to be a minus. And that's going to be a, no, that won't work because of the, yes, it will, minus there as well. That gives me my plus 8. That would give me 4, it's the other way around. Because that's going to give me 12 plus 2, which is going to be too much. Whereas if I do it the other way around, it's going to be 3 times 2, which is 6, and then 4. So that way then, that's fair. So you'll have your minus 2 times minus 4 is going to give you your 8. Minus 4x plus, sorry, minus 6x is going to give you a minus 10x. So if you remember, you need your critical values. So the critical values are 3x minus 4 equal to 0, x minus 2 is equal to 0, 3x equals 4, x equals 4/3, x minus 2 is equal to, I've just done that one, so it needs to be x equals, take the minus 2 over, so that will make it a plus. So we have our critical values, and then from that, we need to decide up to here, where it is less than or equal, or even here where it is less than or equal to 0. Draw a little sketch. So there is 2, there's 4/3, and you want it to be less than or equal to 0, so it's that region underneath. So then the answer is going to be 4/3. Don't forget that it is, so x is greater than or equal to 4/3, but it is less than or equal to 2. There's a reason why I picked this question was because there's another element to it, which is use your answer to part A to find the values of y to satisfy the inequality. Well, it's the same thing. So you just replace your x with 1 over y, and then you invert it, or the reciprocal of it. But when you do so, you're going to have to change the inequalities because of the fact that 4/3 becomes 3 over 4, which is 3/4, and that's going to be bigger than 1/2 because you still want the region underneath. So then this is going to be 3/4, 1/2. Next one, and then last one on modulus. So here we have solved the equation, and again, even though you square both sides, you're going to have to make sure you square that 3. And that one, sorry, I'm on the last sheet before I go on to the differential equations. So what we would do is, again, same thing, 2x plus 1 all squared equals 3 squared x minus 2 all squared. I'm going to sort of I'm going to have to do this one. So that's going to be 4x squared. There's going to be twice the product, so it's going to be plus 4x plus 1 equals 9. And then it's going to be x squared minus 4x. And then that's going to be plus 4. So it would be 4x squared plus 1, and that's going to be 9x squared minus 36x plus 36. And then if I take everything over to the other side, they're all going to be taken away. So it's going to be 5x squared. Then you got the 4x minus, so that's going to be minus 40x. And then you take the 1 over, and that's going to be plus 35. Is equal to 0. If I divide through by 5, I'm going to have x squared minus 8x plus 7 equal to 0. So then it's going to be x. And x, one of them is going to be a 7, the other is going to be a 1. They're both going to be minuses. And then it will be equal to 0. I wrote down the wrong question. I'll put it. This is fine. X minus 1 is equal to 0. X is equal to 1, x minus 7 is equal to 0, so x is equal to 7. Then you go, there's your nice 4 marks for that. 2x squared plus 1, 4x squared, plus the product, so it's going to be 2x, 4x, 1, x squared minus, double that's 4x, plus 4, 9, 9x squared minus 36. Yeah, that's right. Okay, so if we, for the last 10 minutes, if we have a look at these two questions here, which I got here, and then we'll go from there. So we have here the value v of a particular car may be modeled as a continuous variable. At time t years, the rate of decrease of v is directly proportional to v cubed. write down a differential equation satisfied by V. Okay, so you've got here the rate. Okay, so the rate is going to be a decrease of V. So it's going to be dV by dt. That's the start of my differential equation. So dV by dt, the rate of change, that's part A. And then it said that at time t years, the rate of decrease of V is directly proportional, okay, to V cubed, but it's decreased, so it is minus V cubed. Hopefully you can remember this symbol for alpha or use of proportional. If it was inversely proportional, then it would be alpha 1 over, and then it'd be minus V cubed. The next step would be to replace alpha with K. So we have dV by dt equals minus kV cubed, which is our differential equation. It's then told us that given that the initial value of the car is A, show that V squared equals A squared BT plus 1, and that's underneath, where B is a constant. So how are we going to solve this differential equation? Well, we got the initial. So the initial is when t is equal to 0. If I put that there, when t is equal to 0, the value of the car is equal to A. This is differential equation, so I just need to rearrange it so that I can split the anything involving a v is on the left-hand side, so that I integrate with respect to v. Anything else, constant or t value, I'd put on the right-hand side, and then I'd integrate with respect to t. So for part B, what I have is the integral of 1 over v cubed dv equals the integral of minus k dt. Need a bit more space, so I'm going to stick a line straight down. I don't like integrating 1 over v cubed, so I'm going to put it as v to the minus 3 dv equals minus k dt. So your integrating skills is you increase the power and you divide by new power. So it's going to be v to the minus 3. So increasing it is going to put it from minus 3 to minus 2. So it's going to be minus 2 over minus 2. And that is equal to minus kt, and that is plus c. Because it's not a definite integral, because I haven't got the limits either side of it, we have to have a constant, which is c. How we're going to then work that c out is by using our initial values. So we're told when t is equal to 0, v is equal to a. So if I tidy this up on the left-hand side, we have 1 over minus 2v squared is equal to minus k times 0 plus c, and I'll put the a in. So it is 1 over minus 2a squared equals c. Line down. So if I then put all that in, we have minus 1 over 2v squared equals minus kt. And that is equal minus, 1 over minus 2a squared. Since they're all minuses, I'm going to change them to pluses. And I wouldn't mind having this as one fraction. So I'm going to have to times this by 2a squared. So that I have 1 over 2v squared equals kt, I'll put 2 in front, kta squared minus 1 over 2a. That's done a minus minus. Let me change that bit there. I'm trying to account for it twice, so then that becomes a plus. Should be a plus there over 2a squared. Now, if I move this up over to the other side, this up to that side and that down, I will have 2a squared over 2kta squared plus 1 equals 2v squared. Divide this side by 2, so that I have v squared equals a squared over 2kt a squared plus 1. There you go. So my constant b in this is 2k a squared, all constants. So that would be the answer to that for 4 marks. Don't be afraid if you end up with something a bit wacky. If you've sort of done everything correctly and produced everything correctly, then that's the correct answer. Don't worry about it and move on because you've done all the steps correctly. Okay, last one with 6 marks is, so the size n of the population of a small island may be modeled as a continuous variable. At time t years, the rate of increase of n is assumed to be directly proportional to the value of root n. So part A, same thing again, write up a differential equation of, so A is dn by dt, because there's your rate, alpha root n, because it's directly proportional. So then we're going to have dn over dt equals kn, and this one is increasing. Differential equation sorted. Part B then, we're told when t is equal to 5, the size of the population is 256. When t is equal to 7, the size of the population was 400. Find an expression of n in terms of t. Okay, so again, we're going to split everything and move it across. So it is dn, and this time that's going to go down. So I'm going to put that as straight away n to the minus a half, because that's going to be what it is down below. And this is k. Save a little bit of time as we're doing it. So if we integrate this, minus a half increased by 1 is going to give you a half. So divide that. So it is going to be n to the half divided by a half. And that is equal to kt. And again, we've got our plus c. This time, however, we haven't got t is equal to 0. What we end up with is we have 2 values of t. So we have the number 1, which is t equals 5 at n being 256. And we have t equals 7 when n is equal to 400. So we put that in place. This is saying 2. So for the number 1, it's going to be 2 times 256 to the half equals k, and then times t, which is 5 plus c. And then for the other one is going to be 2 times 400 to the half, which is k7 plus c. So what you end up is 2 simultaneous equations. The square root of 256 is 16, and the square root of 400 is 20. So the top one is going to be 40. Sorry, bottom one is going to be 40 equals square root of 400 is 20 times 2 is 40 equals 7k plus c. And then this one is going to be 32 equals 5k plus c. If I was to take those away, that is going to give me 8. That is going to give me 2k, and that's going to go. So k is equal to 4. And over this side, if I have c plus 5 times 4 equals, what was that, 32? C plus 20 equals 32. C is equal to 12. So my differential equation is n equals 4t plus 12 divided by 2. So it's going to be the square root of n equals 2t plus 6, another line, and then the opposite of square root is squared, so that n is equal to 2t plus 6 all squared. And then you're done. I hope that you found this very useful over the last sort of 4 weeks. Myself and Mr. Weatherhead have really enjoyed sort of going through some examples with you. And I'll hand you over now to Mr. Weatherhead.
Thank you very much, Mr. Mackenzie. As he said there, so that's the final A2 session for this year. Okay, we will be back next year. So if you're still working on your maths, then keep an eye out for the details on the e-sgol website. Thank you very much. Goodbye.